Okay, we can look at our do now, which is factoring. Well, when I try to factor this, the problem is that it doesn't equal 0. It needs to equal 0. So in order to set it equal to 0, I'm just going to add 10 to both sides. When I do that, I get n squared minus 11n plus 10 equals 0. Well, first I'm going to do is I'm going to take the 1 out front, multiply it by 10. What's 1 times 10? 10. I'm looking for two numbers that multiply together to give you 10. But when you add those same numbers together, we're looking for negative 11. So hopefully you can see that's going to be negative 1 times negative 10. So I put this over to the side, negative 1 and negative 10. I'm going to divide both things by 1 because that's the a value. They don't reduce because a is 1, so the coefficient's 1, so we put x there. So my factors are going to be x minus 1, x minus 10, set that equal to 0, and then we solve each one of these. So I'm going to do x minus 1 equals 0, add 1 to both sides, we get x equals 1, and then over here, x minus 10 equals 0, we're going to add 10 to both sides, we get x equals 10. If I'm really trying to impress my Algebra 1 teacher, I'd write x equals squiggly brackets 1 comma 10. That's where this quadratic crosses the x-axis on the graph. Okay, let's take a second to talk about postulates and theorems. First thing I'm going to talk about is postulates. We have the most you guys ever heard about is theorems. Like you've heard of Pythagorean theorem. In here today, we're going to do segment addition postulate. There are going to be some theorems we're going to talk about. So the difference between the two. So Euclid, that old guy that created Euclidean geometry, he had to create a set of rules, things that we as his people that study it assume to be true. So what he decided is he decided what points look like, planes, rays, line segments, all those things. And then he decided to talk about some postulates. Now, postulates are something that we assume to be true. They're like a rule. Or a definition. Those would be good examples. A theorem is a theory. You can see the word theory in there. It's a theory that Euclid proved. So what Euclid did was he came up with these rules or these definitions, and then he came up with some theories that he thought would also work based off of those rules and definitions and postulates he created. So he came up with these theorems. Well, Pythagorean theorem was something that somebody came up with back in the day, Mr. Pythagoras, and he decided, okay, I got this theory, I got this idea. Does this always work? And he tested it out and he proved that Pythagorean theorem will always be true. Okay, so it's a theory that Euclid had to prove. It's not something we can just take as truth. So it's an idea or a theory. So see if you can write the difference between postulate and theorem here in this box. Okay, we already touched base on this, but I want to put it in your notes. Formulae, congruent versus distance. Okay, we talked about if we're trying to find the distance between. Okay, the distance between any 2 points is written like this. A, B. Nothing fancy. So in this case, if we look up here at the picture, AB is going to be 4. Congruency is a different story because congruency is saying that they appear to be the same size, same shape. So if two line segments measure the same distance, we say that they are congruent. Okay, this looks a little bit different. When we write congruency, we have to write it like this. We write line segment AB is congruent to, that's a congruency sign. That means congruent to line segment CD. That's just an equal sign with a fancy tilde on it. That means congruent. So segment addition postulate is something that Euclid said will always be true. It works no matter what. So if points A, B, and C are collinear, and point B is between A and C, okay, so B has to be in between, what we know is AB, when I take the distance from A to B, I add that to the distance from B to C. What's the total length going to be? The whole distance, which is AC. Hopefully that seems like common sense. If I add together two pieces, they're going to equal the total long piece. So if I come over here to my picture, it says PQ equals 7. I'm going to label it. I always label. It says QR equals 12. Well, if I want to figure out what the whole distance is, I just do 7 plus 12. 7 plus 12 is 19. So PR equals 19. So if I come to example 2, it says PQ equals 7. But P to R, that's the entire thing here. The entire thing, P to R, is 23. How do I get QR? Well, hopefully you're just going to take 23 and subtract 7 from it. Or you can set this up as an equation, 7 plus x equals 23. Well, 23 minus 7 is 16. Okay, again, you can do it two different ways. You can do 7 plus x equals 23 and solve. Or you can just subtract 7 from 23 to get x equals 16. Okay, some guided practice here. B is between A and C. So if I draw a picture of that, I have B. I have B is between A and C. So I'm going to have A, C, and B is somewhere in between. It's not the midpoint. It just says it's somewhere in between. Okay, it says AB is 3x plus 5. So AB, I'm going to mark this as 3x plus 5. And it says B to C is 2x plus 8. And AC is equal to 88. So A to C, that's the whole thing, is 88. How would you set up an equation? You take the two pieces, so that's 3x plus 5. You're going to take that piece, you're going to add it to BC, which is 2x plus 8. And you're going to set that equal to the total. What's the total? 88. So from here, we're just going to do our algebra. We're going to combine like terms. 3x plus 2x is 5x. Plus 5 plus 8 is 13. Equals 88. Subtract 13 from both sides. We get 5x equals 88 minus 13 is 75. Divide both sides by 5. And we end up getting x. I'm going to write this up above because I ran out of room. If you don't have a calculator, don't forget, you can always go to your calculator on your Chromebook. 75 divided by 5 is 15. So x equals 15. How do I check my answer? Plug it back in. 3 times 15 is 45 plus 5 is 50, so AB equals 50. 2 times 15 is 30 plus 8 is 38. What's 50 plus 38? 88, good. So this says point O is between CW. Okay, it says O is between. It says nothing about a midpoint. So just because that looks like it's in the middle, it doesn't mean that it is. So if I want to do this, I'm going to go ahead and add together my two pieces. So x plus 4 plus 3x plus 7. And I'm going to set that equal to the total, which is 43. Combine your like terms. You get 4x plus 11, equals 43. Subtract 11 from both sides. 4x equals 32. Divide both sides by 4. And you get x equals 8. How do I check my answer? I plug it back in. 8 plus 4 is 12. 3 times 8, 24 plus 7, 31. And what's 12 plus 31? 43. So good job. Okay, so for your homework, go to deltamath.com. You're looking for the assignment that says HA number 1-3 Sigma Addition Postulate. If you did not sign up for Delta Math on Tuesday, then you're going to either need to send me an email if you need some help, or you're going to have to go find